Okay, so we were discussing magnetic forces, and we have yesterday talked about a charge inside the magnetic field, and I told you that when a charge is placed inside the magnetic field, it experiences a force, and that force is given by this expression, which is Q, the charge, times the velocity, times the magnetic field, times the sine of the angle between the velocity and the magnetic field. So yesterday we have done this, okay, and we also tried to understand how to evaluate the direction of this force. The direction of this force is evaluated with the help of the right hand rule, which has to be used in a way that your finger should start from the velocity and terminate at the magnetic field. Okay, so yesterday I think we reached this point here, and this question was to be discussed. Let us try to solve this numerical. An electron in an old style television picture tube moves towards the front of the tube with a speed of, so the speed of the electron is given, the velocity is given, okay, the velocity is along the x-axis, okay, this is the x-axis. Surrounding the neck of the tube are the coils of the wire that create a magnetic field of magnitude. So there is a magnetic field of magnitude 0.025 Tesla directed at an angle of 60 degrees. So the angle is also given, fine. And lying in the xy plane. Calculate the magnetic force of the electron. Come on. Calculate the force on this electron when angle is given 60 degrees. Velocity is given 8 times 10 to the power 6 meter per second, and magnetic field is also given, which is 0.025 Tesla. Okay, you are asked to find the force on this electron. Come on, tell me, how do you find the force? Yeah, the formula is, yesterday we discussed the formula, you were not here. So this expression is for the formula. The force is given by charge, the magnitude, times velocity, times magnetic field, times sine of the angle. Fine. But to find the direction, if you remember, yesterday I told you, start from velocity, use your right hand, start from velocity and curl your fingers towards the magnetic field. Thumb gives you the direction of the force. You start from velocity, go towards the magnetic field, curl your fingers towards the magnetic field, and thumb will give you the direction of the force. Is that fine? Or the other way that I told you how to find the direction? The direction can also be found by understanding the concept of I, J and K. So yesterday I told you this. If you have I, J and K, if you are going in the clockwise direction, it will be positive. And if you are going in the counterclockwise direction, it would be negative. Okay? So that we have discussed yesterday, I think. If you go like this, it would be negative. And you need to understand, I cross J will give you K, K cross I will give you J, and J cross K will give you I. That's it. So here we have to evaluate the force, and also we'll try to find the direction of this force. So understand the axes which are given. This is the x-axis, this is the y-axis, and this is the z-axis. Okay. So you're asked to find the magnetic force on this electron. So the charge is negative. And what did I tell you about the negative charge yesterday? That the force, the direction that is obtained by the right hand rule, it will be reversed for the negative charge, isn't it? So first of all, let us find the magnitude, then we will find the direction. Yes. What is the value of the magnetic force? Q is the charge. So the charge is an electron. What is the electronic charge? Yes, 1 point times 19 coulombs, isn't it? So you have everything. You are just asked to find the force. You try to find the force, yeah. 2.7 times 10 to the power negative 1/4. Anyone else with the same value of the force? Yes? Anyone else with the same value? No? You have the expression, right?
Yes, it's correct.
It's correct? The expression that you would use is this. Okay, let's try to see. Yeah, the expression, your answer is correct. So see, the velocity is 8, the magnetic field is given, charge is that of an electron, and electronic charge is this, the angle is 60 degrees. Now, in order to find the magnitude of the force, the expression that we will use is QVB sine theta. Don't use the negative sign here because we are just evaluating the magnitude of the force. But now, when you have to find the direction, very important. So first of all, like yesterday, we will be using the right hand rule, according to which you have to start from velocity and move towards the magnetic field, correct? So if you go to this problem again and you try to find the direction of the velocity, so velocity is somewhere along x, isn't it? So the velocity is like this. The magnetic field is somewhere here, so it is like this, see? Something like this. Velocity is there, the magnetic field is here. The angle between the velocity and the magnetic field is 60 degrees. This is the question. So we have to find the direction of the force. How do you find the direction of the force? Yes, I told you. Start from the velocity, move towards the magnetic field. The thumb will give you the direction of the force. So the force is upwards, correct? But this is a electron is negative, therefore we have to reverse the direction. So the direction of the force will be downwards, and that will be this. Is it clear? Is it clear? Now one more thing, you can also do the same with the help of the, what is this called? The I cross J thing as well. This is downwards, the right hand rule helps you, I cross J, cross K, whatever, it can also help. It depends on how you find it easy, you can do that. Is that fine? That is it. Okay, now we have another question. Now try to solve it at your place. Come on. An electron is moving with some velocity, the velocity is given. 1.25 Tesla, magnetic field is also given. The force is also given, 1.4 times 10 to the power negative 16. The question is, what is the angle between the velocity of the electron and the magnetic field? So you have to find the angle. The question is, find the angle. Come on, tell me. Yes. Hiba, find the angle. Mike, come on, do it. Find the angle. 1.25 Tesla is the magnetic field. Where do we get the field? So yesterday I was teaching you the but you can take the not for physics, you can take it 20 minutes. Yesterday actually they were from, so I only got the room, that's it. The guys from the head office.
You can do your own so you take.
So what you have to do here, you again use the expressions that the magnetic force is given by QVB times sine of theta, okay? Now the force, what is the force? 1.4 times 10 to the power negative 16, correct? What is the value of Q? 1.6 times 10 to the power negative 19. What is the velocity? 4 times 10 to the power 3. What is the magnetic field? 1.25 times sine of the angle. So you just have to solve this equation. You will get sine of the angle, isn't it? So the sine of the angle that you are going to get will be, yes, can anyone tell me? 10.08. Is that fine? So you want to find the angle. How do you find the angle? By taking the inverse here. So theta would be sine inverse 10.08. Come on, tell me what is the value now.
No, Mr. The angle is not going to do.
The angle is?
Yes.
So that is the angle. No, tell me the value of this without the, I want the value of sine of theta. What is the value of sine of theta? Yes. I want the value of sine of theta.
0.175.
0.175. Now take sine inverse of 0.175. That gives you what? 10?
Yes, 10.0.
Degrees. So this is the value of that. Is it clear? Fine? Any problem in this? If there is no problem, then yeah, 10 degrees is correct. Yeah? Okay. Fine? Okay, now, come on, solve this question. The first person who solves this except Agreed will be rewarded. Not even Fatima, Muhammad, because you are there. Well, Muhammad, okay. Then this is.
The first one or second?
Both. Because I told you already. Isn't this Lego? I purchased a transformer and so you brought it here to.
We had 15 minutes break. Serious was.
Yeah, good, very good. Doing for me, right? Yes, Mike. Do it, come on. Come on, you have to do it. Hiba, come on, you have to do it. You have the expression. You have to determine the magnitude and the direction of the field. Of the field. Yes. She said, one student used to tell, I like so numeric. It is numbers.
Yeah, but
You want an easy question? Salma, yeah?
Because you don't like the direction. The second test.
What? But what? HP.
No, the second one.
I don't know. 3 times 10 to the power negative. But I asked you to solve both.
2.5.
2.09
multiplied by 10 to the power
minus 2 for the first one? Okay, anyone else? But what about the direction of the field? What about the direction of the field? Negative J? Okay. Okay, anyone else? By the way, your papers are ready for Saturday. Please solve the paper. Because as I told you, you will be evaluated on that. So don't skip your paper, because when you don't attempt, you already are at 0. The assignment, the weekly test. Fine? Okay, let's try to solve this question here. I want all the values. Please click a picture so that when I ask, you have to tell me. A proton moves perpendicular to a uniform magnetic field at a speed. So the speed is given. And experiences an acceleration of 2 times this. Okay? Acceleration is given. So when acceleration is given, what does that mean? Do you have the mass of proton? Yes? When you have the mass of the proton, you have the acceleration. Can we find the force? So we have the force. In the positive x direction. So the acceleration, that means the force is in the positive x direction. Fine? When its velocity is in the positive z direction, very important. The velocity is in positive z direction. The force is in positive. Yes? Isn't it? The question is, what is the direction and the magnitude of the magnetic field? So you need to understand, force is already here, velocity is here, something like this. Fine. So that means our magnetic field by the concept of the right hand should be something like this. See, when you start from velocity, you have to go to the magnetic field, isn't it? Such that the thumb should point like this, isn't it? So when you try to curl your fingers are going down. It means the magnetic field had to be along a negative J. Khalas. We have to find the value, we can find that, okay? So let us try to evaluate this question. See, how do you solve the question? The first thing, the force is something like this. The acceleration is given. What is the value of the acceleration? Yes? Yes? What is the value of the acceleration? 2 times 10 to the power 13 meter per second square. Okay, this is the acceleration. Also that the velocity is along the z-axis, isn't it? This is z, this is x, and this velocity is how much? What is the velocity? The velocity is 1 into 10 to the power 7. 1 times 10 to the power 7 meter per second. Okay? What else is given? In the positive z direction, we have to determine the magnitude and the direction of the magnetic field. Now see, what is this? A proton. So there is a proton which is moving like this. There is a proton. And you know the charge of the proton is 1.6 times 10 to the power negative 19 coulombs. And you also know that the mass of the proton is equal to 1.6 times 10 to the power negative 27 kgs. Do you know this? Yes? No? The mass of the proton is 1.6. Okay, mass of an electron is 9.1 times 10 to the power negative. So remember these things. Why would you forget? Mass of electron is 9.1, 10 to the power negative 31 kgs. Okay, but for a proton it is much heavier, so it is 1.67 rather times 10 to the power negative 27 kgs. Is that fine? Now we have to find the direction of the magnetic field. First of all, we need to understand if the acceleration is given, can we find the force on this body? Yes. Let us evaluate the force. What is the force that this proton is experiencing? Because it has some acceleration now. So force, you know, it is mass times the acceleration, right? Isn't it? So what is the mass? It is 1.67 times 10 to the power, yes, negative 27, isn't it? Times the acceleration, which is 2 times 10 to the power 30. Can you find me the result for the force?
3.34.
3.34 times 10 to the power negative 14 Newton. So we got the force, that's it, class. When we have the force, we already know the concept that this is the magnetic force, and the magnetic force is given by, yes, QVB sine of theta, isn't it? Yes. Can you tell me what is the charge? What is the value of the charge? 1.602 10 to the power negative 19, correct? Times what is the velocity? The velocity is given 1 times 10 to the power 7, which is simply 10 to the power 7. What is the magnetic field? We do not know the magnetic field. Let it be B times sine of the angle. What is the angle between the velocity and the magnetic field? Yes. What is the angle between the velocity and the magnetic field here? You have to be very smart while you are thinking about it. Yes. See, very important. In this direction our force is there, right? And in this direction we have our velocity, correct? Correct? Yeah, of course. So, I have already told you, whenever we have to find the direction of the force, we are using what? The right hand rule, correct? And the right hand rule says, start from velocity and go towards the magnetic field, isn't it? Now, because the magnetic field is along which direction? The positive x-axis. So thumb has to be here, correct? Point your thumb towards the force. Point your fingers towards the velocity. So when you try to curl it, see what is happening? The magnetic field had to be somewhere here, correct? So the magnetic field is along the negative j-axis. That means it is the y-axis. So what is the angle between velocity and magnetic field now? It is 90 degrees. Khalas. So it is 90 degrees. Is it clear? And that means our magnetic field is actually here. This is the magnetic field. Fine. So now everything is clear. This is x. This is the negative j, and this is the velocity, which is along positive k. As I have already told you, what are these unit vectors? We can also find the direction with the help of unit vectors. Fine. So when you try to do this, what will you get? Tell me the value. Come on. Sine 90 is 1. Khalas. So we don't need to evaluate this. So tell me the answer. It is 3.34 times 10 to the power negative 14 is equal to 1.602 times 10 to the power negative 12 times the magnetic field. Come on, solve this equation for the magnetic field. What is the value of the magnetic field? Yes? Divide this 3.34 by 1.602 times 10 to the... So this will be actually minus 2. It will be somewhere around 2. Yeah. So it is 200, something like that. Or 0.02, something like that. 0. Yeah. 0 point?
0.
That's it?
0.0208.
Okay. Tesla. Khalas. This is the magnetic field, and this magnetic field is downwards. Is that clear? Is it fine? So this is how you have to understand. Now, if you can also find the direction of the force. You know that the force is along I cap. You know that the magnetic field is along K cap. The velocity is along K cap. And if yesterday I told you something about this. See, I, J, and K. I told you when you go in the clockwise manner, everything is positive. Fine. So here we have to check velocity. Velocity is K, and magnetic field has to be negative J. Then only we'll get I. So K times something has to be I. See, K times something is equal to I. So we have to evaluate. K times something has to be positive I. Very important, very important. So when you start from K and go towards J, you will get, what will you get? You will get negative I, isn't it? Correct? But we have to have what? Positive I. In order to have a product which is positive, therefore either K should be negative or this should be negative, isn't it? But K is already fixed. We know that it is along the positive ZX. Fine. Therefore this has to be negative. So this cannot be J. This has to be what? Negative J. Also direction is confirmed from this. We don't need to use the rule right hand rule. Just understand this. This will also help you. Is it clear? Is this fine? Okay. Now the other question. The other question. Come on, try to do this now yourself. You want to copy this? Or you did it already? Okay. What value did you get for the first one?
2.09 multiplied by 10.
Done? Okay, now let us try to do this question here. A cosmic ray proton, again we have a proton, moving towards the earth. The speed is given 5 times 10 to the power 7. Experiences a magnetic force 1.7 times 10 to the power negative 16 newtons. What is the strength of the magnetic field if there is an angle 45 degree between it and the proton's velocity? Come on, tell me. We can do this. Very easy. Yes. So there is again a proton. The charge is positive. Velocity is given. Magnetic force is given. You have to find the strength of the magnetic field. So you have to find the B. Angle is also given. Fine. So what we will do? Yes. What is the velocity? What is the angle? And what is the force? Tell me. How much is the velocity? 5 times 10 to the power 7? 5 times 10 to the power 7 meter per second, correct? What is the angle? 45 degrees. And what is the force?
1.7.
1.7 times 10 to the power negative 16 newtons. Okay. The question is, what is the magnetic field? The strength of the magnetic field. So this proton, the cosmic proton, is trying to approach. It is coming from the universe, okay? It's approaching Earth. So the question is, what is the magnetic field? When its velocity is this, the angle between the magnetic field and the velocity is 45 degrees, okay? What is the angle? What is the strength of the magnetic field if there is an angle between it and the proton's velocity? Yeah. So the angle between velocity and magnetic field is 45 degrees. So how do we evaluate it? We know the expression FB is equal to S QVB sine of theta, correct? Yes or no?
Yes.
So let us try to use this expression to evaluate the value. What is the value? So it is 1.7 times 10 to the power negative 16. Charge, what is the charge of proton? 1.602 times 10 to the power negative 19 times. The velocity is given 5 times 10 to the power 7. Okay. Magnetic field is we have to find times sine of 45 degrees. Now come on, give me the value of the magnetic field. Yes. 3 times 10 to the power negative 5 Tesla. This is it. You found the same value? Okay, good. That is it. Khalas. Is it clear how do you use the right hand rule now? Or is there any doubt? Yes, Khalifa? No. Okay. One important thing, like we discussed it yesterday as well. So, very important, very important. This is the motion of a charged particle inside the uniform magnetic field. So, we have a magnetic field already depicted by lines which are equidistant, okay, they are parallel, so it is uniform magnetic field. And then there is a charge, this charge, Q. It can be anything, it can be positive or negative. And it is going with some velocity v. Either it is going along the magnetic field or in this case it is going against the magnetic field. Fine? The charge is Q. The thing is, here what is the angle between the velocity and the magnetic field? Yes? What is the angle between the velocity and the magnetic field here? Is it 0 degrees? What is the angle here? 180 degrees. So yesterday I have already told you, when you talk about the force at these two angles, 0 degree and 180 degrees, we do not observe any force because sine of 0 is 0, sine of 180 is also 0. So there is no force on this charged particle, be it positive or negative. And very important thing, that means the velocity of this particle will be constant, it will not change because there is no force. When there is no force, that means there will be no acceleration of the system as well. Is it clear? So this is really important. But the charged particle will continue to be on its path, its direction will not change, its velocity will not change, nothing is going to happen. It is as if it is all of it on its own. It is in isolation. Fine? Clear? But then we are firing a particle inside the magnetic field, but remember, at an angle of 90, that is at perpendicular angles. Fine? See, very important here. We have a magnetic field which is shown by cross. What does that mean? What is the direction of the magnetic field? Inwards. Fine? Remember, very important thing. In such cases where the magnetic field is perpendicular to the velocity, where the magnetic field is what? Perpendicular to the velocity. Remember, the particle's speed does not change. But what happens is, the direction of its motion changes. And we are observing that in such cases, when the particle is fired perpendicular to the magnetic fields, the force experienced by the particle compels it to go around a circular path. So what is happening? Try to understand. For a special case of the charged particle moving perpendicular to the magnetic field, the resulting motion will be that of a uniform circular motion. Very important. It will be a uniform circular motion with the magnetic force acting as the centripetal force. So what is happening? Let me show you. In this case here, for example, this is a charged particle, okay, and it has some velocity v which is towards the positive x direction, okay. The magnetic field is inwards. See, something like this is happening, very important, keep an eye. The velocity is there and the magnetic field is inwards, fine. Now what will happen? See what will happen. This charged particle wants to go like this and the magnetic field is inwards, correct? So if we check the right hand rule and we check the direction of the force, we will obtain it like this. From velocity, go towards the magnetic field. So the force is up, isn't it? That means the force on this charged particle is trying to take it up. It wanted to go straight, but the force is compelling it to go up. Therefore, what will it do? It will go through the resultant motion. Is that fine? Through that resultant motion. But the moment it is here, see, very important. Here, when it is here, what is happening? Now the velocity is something like this, and the magnetic field is still inwards, fine? Again you are seeing, see? Now the particle wanted to go like this, but still the force is pulling it up. That means it is still going up. And what will happen? It will go like this. Now the moment it is here, the velocity is up and the magnetic field is in. The velocity is up and the magnetic field is in. So when you go for V cross B, the magnetic field again is showing towards the center. So at each and every point, what we are seeing is that the magnetic force is directed towards the center. So now it is going here. That means at the top it wants to go like this. The magnetic field is in, the velocity is something like this. And when you check the direction of the force, see what is happening. The direction of the force in this case, velocity is there, magnetic field is inwards. So V cross B, force is downwards now. So the force here is downwards. And now the particle will try to come back. At this point, velocity is something like this. So velocity is down, magnetic field is in. Again, when you go for V cross B, force is directed towards the center. This force is trying to direct the body towards the center, and therefore this force is called as the centripetal force, something that you have discussed in the circular motion as well. This force only changes the direction. This does not change the magnitude of the speed. The speed remains the same. That is why the speed is called, the motion is called as uniform circular motion. It is circular because the path is changing, the force is directed towards the center, and it is the maximum force. The magnetic field and the velocity are at 90 degrees at every time. So the force, the magnetic force is maximum and it is equal to QVB only. This is the maximum force. Fine. And remember, this force, because it is directed towards the center, gives rise to the centripetal force, which is necessary for the circular motion. Fine. So if I try to equate, do you know what is the value of the centripetal force for a circle? What is the value of the centripetal force for any circular motion? Remember, it is always mass times velocity square upon the radius of the circle. Fine. So that means if there is a circular motion going on and the velocity of the particle is v, okay, like in this case, the radius of this path is r and the particle has a mass m, okay, the required centripetal force so that this body continues to be in the circular motion is mv square by r. Fine. But in this case, the case that we are discussing, there is magnetic field as well, which is inwards, is it? So due to this magnetic field, we are having a magnetic force which is towards the center, and that magnetic field magnetic force is something like this. This is the magnetic force which is towards the center. So this magnetic force gives rise to this force. But what is the value of the magnetic force? Yes? The magnetic force, as I told you, it is Q times V times B, the maximum. So what will happen is, this magnetic force will give rise to centripetal force. That means the two will be equal. So in entrance, in your examinations, they will ask you two things. One, They can ask you, what is the radius of the circular path? What is the time period in which it will complete one circle? How many circles will it complete in 1 second? Everything can be derived from this. So the first thing that we are going to do is find the radius of the circular path. So the radius of the circular path can be found by, yes, the expression mv square upon qvb. Is that fine? We can find it like this. This is the radius of the circular path. So mv square upon r is the centripetal force. We equated that with the magnetic force and we tried to find the radius of the circular path. This is one of the things that they can ask. The second thing that they will ask can be, how much time will it take to complete one circle? How much time will it take to complete one circle? Do you know, for that, we have the expression that velocity is equal to distance over time. Yes? What is the distance that the particle will cover? Yes? It will be 2 times pi times the radius, isn't it? Upon the time, correct? So we can find the time as well. The time will be equal to 2 pi r upon the velocity. Whatever velocity it has. Is that fine? If someone tells you how many cycles will it complete, so we can find another thing that will be called as the frequency. And that frequency can be found by the reciprocal velocity upon 2 pi r. Is that clear? Fine. These are all the things that we can find. So here, if you want to simplify it, you can cancel the velocity and this velocity. So the simplified version would be mv upon qv. Is that clear? It depends on what they ask. So remember, when a particle is fired along or anti-parallel, no force. But when the particle is fired perpendicular, maximum force. And that maximum force only changes the direction and the particle starts to go in circular motion. And the circular motion has a radius of mv upon qb. The time period that it takes is 2 pi r upon v. The frequency is v upon 2 pi r. So questions can be asked like this as well. Fine? Solve a numerical, come on. Write it down, write all the expressions, we have to solve the question. So whenever questions are asked, always try to use for the direction, use your right hand rule, and for the expression, try to start from here, always. This is the basic thing, that the centripetal is equal to the magnetic force. That is it. Write everything down, we'll go for a numerical. This is the radius mv upon qb, time period 2 pi r upon v, frequency v upon 2 pi r. Okay?
Stop.
Yeah.
What's the color?
What is what?
Number 3.
The frequency, number of cycles, number of circles it completes in 1 second. F, yeah, small f. Hiba, write down the question. The question. The question, yeah. This is different. An alpha particle is fired perpendicular. An alpha particle is fired perpendicular to a magnetic field as shown. Okay? okay, with a velocity of 2 times 10 to the power 7 meter per second. Okay? With a velocity of 2 times 10 to the power 7 meter per second. Fine? Find the magnetic force, direction of circular loop, the radius, frequency, and the time period. The diagram is this. This is the magnetic field, and I am writing it as outwards, okay? The question is, if an alpha particle is fired, something like this. This is the alpha particle which is being fired. The question is, show the direction of the circular loop. What will be this? How will the circle be formed? Will it be clockwise or anti-clockwise? The second thing, find the magnetic force, find the radius of the circular loop, the frequency and the time period as well. Come on, do this. The guy who does this first will be rewarded. Rewarded, yeah. You have to check that. You have to see yourselves what will be the direction of the force. The previous, yeah, I will. This is cross, and the particle was fired like this. In this case, the particle was fired like this. And it went up. See? Here, the particle was fired like this, but it went up. Why? Because the magnetic field was inwards. I'll again show. See, how do you evaluate? Magnetic field is in, velocity is there. Fine? Start it there. So, it goes up. Up means anti-clockwise. Fine? In this case. But here you have to check it yourself. Check it yourself and tell me. Check the direction of the magnetic field. Check the velocity. So velocity is here. Velocity. Other slide. This. Come on, try to do this. Very important. Down?
No, up.
Up?
Yes.
Will it move in clockwise direction or anti-clockwise direction?
Can you read it?
An alpha particle is fired perpendicular to a magnetic field as shown. with a velocity of 2 times 10 to the power 7 meter per second. Find the magnetic force, direction of the circular loop, the radius of the circular path, frequency, and the time period as well. That is why I know some of you were busy while I was showing it for the other case. Yes, Rauta?
Yes.
See, I'll again teach you this. Very important. I told you whenever the particle is fired perpendicular, the force is maximum. Okay? And what is the value of that force? Yes? Q times V times B. Okay? This is the maximum force. And what is the charge that is being fired? An alpha particle. The charge of an alpha particle is 2 times that of a proton. So that means it will be 2 times, what is the protonic charge? 1.602 times 10 to the power negative 19. Okay? What is the velocity? 2 times 10 to the power 7. Okay? And times, what is the magnetic field? The magnetic field is not given, so let it be 20 Tesla. So this is times 20. Khalas, this will give you the maximum force. Fine, the force is there. But we have to check the direction of the force. How do you check the direction? Again, understand what I am doing. The magnetic field is outward, so let this be the magnetic field. The velocity of the particle is like this. Okay? So what is happening? V cross B. We go from velocity towards the magnetic field. From velocity towards the magnetic. So it means up. That means the force at this point is upwards. This is the magnetic force. So this force will cause it to go like this. But then it will try to go up. Up means it will go like this. The moment it goes up, now see what is happening. That is the important thing. The moment it is here, it is going up. Now the velocity is upwards and the magnetic field is outwards, isn't it? See what is happening. Velocity is now up because the force was upwards, right? Due to that, the particle is going up. Now when it is going up, the magnetic field is outwards. V cross B. Now, don't go up, come back. This is the force. So what it does, it goes up, and now it tries to go like this. Now it is going like this. So the velocity is there, and the magnetic field is out, isn't it? Now what will be the direction of the force? See, V cross B, it is down. So now the magnetic force has started to act downwards. So that means it won't go straight, it will try to come down. The moment it tries to come down, now the velocity is downwards and the magnetic field is outwards. Check the direction again now. V cross B. V cross B. It is towards the center, see? Therefore it goes, so this is the circle, correct? This is the circle. So when the circle is formed, what we are seeing is the force at each and every point is towards the center, towards the center, towards the center. And the path of this body is circular, and the body is moving in which direction? Now, clockwise or counterclockwise? Clockwise, khalas. So, tell me the value of the force. Tell me the value. 2 times 2 is 4, 4 is 16, 160, 16, 256 something, 25 something. 25 something, is it? No? How is it 1.28? 2 times 2 is 4. 4.
I also got the same answer.
What?
1.28.
1 times
10 to the power negative 10.
That's it?
Yes.
See, this is the force. This is the force, and this force has caused the body to move in a circular path. Okay? And now we can evaluate the other things. the body, due to this force, the body is going in clockwise direction. Is that fine? The motion of the circular path is clockwise. Fine? Now the second question, what is the radius? So for the radius, we have another expression. Right? What is the expression for the radius? mv upon qb, isn't it?
Yes.
So what is the mass of this alpha particle? Mass of alpha particle is so important. Charge of alpha is 2 times charge of proton. Okay? But mass of alpha is 4 times the mass of proton. Is that clear? Because alpha particle is a helium atom in which 2 electrons have been taken out. Fine? Therefore the mass is 4 times. So we have to write 4 times the mass of proton. What is the mass of proton? 1.10 to the power negative 27, isn't it? Times the velocity. What is the velocity? 2 times 10 to the power 7 upon charge 1.602 times 10 to the power negative 19 times the magnetic field, which is 20. Find me the value for the radius. Come on. Find me the value of the radius. Yes, the radius is 4 something. 0 point? Khalas?
Yeah, 169.
Meters, right? Isn't it? So the circular path is actually 4 centimeters of radius. Is that fine? Clear? The next thing is the frequency and the time period. Can you find that? You have the expression. You already know the radius, you can put it. What will be the time period? Yes? The time period would be 2 pi 0.04 upon the velocity, and which is 2 times 10 to the power 7. Correct? Isn't it? So the time period is how much? Yes? 2 and 2 cancels out. So it is 1 point times 10 to the power seconds. Okay? Therefore the frequency would be the reciprocal, right? And what is that? 79 million.
577.
79
577.
577
47.
47
1.
1
1.5.
point 1 471 0.5 hertz, the unit. That means the particle is making this many cycles in 1 second. These are particle accelerators. Do you know there is a device called as the cyclotron? It uses the same principle. When it is going in a circular path for a long time, you know, you gain momentum, and then they throw it, right? The handball. That is what they do. They rotate so many times and they gain the momentum and then they throw it. Particle accelerators do the same thing. This is the principle behind a device called as the cyclotron. That the charged particles are fired perpendicular to the magnetic field, they revolve in circular paths, and the moment they gain enough velocity, they are thrown out. Yeah. Is it clear? If it is clear, I will stop here with this last thing. There is a magnetic field something like this. Just show me the direction of the circular loop. A particle is fired, a neutron is fired like this. Okay? With some velocity v. Tell me what is the path. Tell me what is the path. Can you give me the path? The magnetic field is inwards, the velocity is down, correct? So we have to go from velocity to magnetic field, velocity to magnetic field, velocity to magnetic field. So what will be the path then? Will it go towards right? Then of course it will go like this, right? Isn't it? So is the path clockwise or counterclockwise? Counterclockwise, isn't it? Counterclockwise. But what was fired? What was fired? Yes? Neutron, isn't it? So the force experienced by the neutron is Q times V times V, isn't it? What is the charge of neutron? What is the charge of neutron? Zero. So when it is zero, the force is zero. It doesn't experience any force. How will it form a circular path? Because I told you, this is when there is a charged particle. This is a neutral. When the body is neutral, it will continue to be on its path. It will not form a circular path. Is it clear? Force is only experienced when there is charge. When there is no charge, there is no force. Is that clear? With this, I will stop here. Tomorrow, I will be discussing when it is fired at an angle. And that angle will give you the helical path. Thank you so much.